Hi everyone, so now we're going to be talking about combination exponents. Basically, we're going to combine the product rule, the power rule, and the quotient rule in some of these examples. So it's everything that we've already learned, we're just going to mash them together. So let's go through the first example, which says 2xy to the fourth times 6x squared y over 4 x to the fourth y squared. So this is a combination of the product rule and the quotient rule. What we're going to do when you see something like this, it's the easiest for me to start with the product rule and simplify the top and then simplify the bottom, and then we can use the quotient rule. So I'm going to start by just simplifying the top. Now on the top we have a 2 and a 6 is the coefficients, those big numbers. So we can just multiply those. 2 times 6 is 12. And then for our x's, this one right here is x to the first power because it doesn't have an exponent. So for our x's, we're going to have x. The power rule says we add the exponent, so 1 plus 2. And then y, this y should have a 1 because it doesn't have an exponent. 4 plus 1. So that's the top. And then the bottom we can just rewrite as 4x to the fourth y squared. We're going to simplify the top a little bit by saying, okay, well, I'm just going to actually add the exponents together now. It'd be x to the third, y to the fifth. And once again, we didn't change the bottom, so we're just going to rewrite the bottom. And now we can use the quotient rule to simplify the fraction as a whole. So you've got a 12 and a 4 as your coefficients. We can actually divide those things. So 12 divided by 4 gives me 3. When I get a number like that, I'm going to just put it on the top of the fraction. So because 12 divided by 4 is 3, 3 goes on the top. Now for our x's, we look for which one has the highest exponent. Is it on the top or the bottom? The bottom one has the highest exponent, so I'm going to put the x's on the bottom, and it would be 4 minus 3, because the quotient rule says I subtract. And then for the y's, which one has the highest exponent? Well, the one on the top has the highest exponent, so I'm going to put the y's on the top. It'd be y to the power of 5 minus 2. Okay, now we can simplify that. We've got the 3 from the coefficients, and then 5 minus 2 gives me 3, so y to the third. And then on the bottom we have x to the fourth minus 3. 4 minus 3 is 1, so just x to the first. And that is our answer. So these ones take a little bit longer, but they use the same exact rules, which is nice. Okay, so let's look at the second example. The second example is 3x cubed y squared times 3x squared y to the third. So this one is a combination of the product rule and the power rule. In this case, when you have that power rule that goes on the outside of everything, it's easiest to simplify the inside of the parentheses first and then deal with the power portion. So I'm going to do the product rule first, which I'm going to do this 3 and this 3. Those are both coefficients, so I'm going to actually multiply those together, which gives me 9. And then our x's would be x to the third plus 2. And then our y's will be y to the squared plus 1, because this one, because it doesn't have an exponent, is 1. And I'm going to put that 3 there just because we don't want to forget that we have to do the power rule as well. I'm going to simplify that a little bit by just adding the actual exponent. So we're going to have 9x to the fifth, y to the third, all to the power of 3. Now we can use our power rule and distribute that 3 to the 9, the x, and the y, which will give us 9 to the third, x to the fifth times 3, because that's what the power rule says. If we're taking it to the power, we're actually multiplying the exponents. And then y 3 times 3. Okay, so now I'm going to use my calculator and figure out what 9 to the third is, which is 729. And then we would have x, 5 times 3 is 15, so x to the 15th. And y, 3 times 3 is 9, so y to the 9th. And there we have it. This is our simplified answer. All right, let's go to the next example. The next example looks like this: 2x to the fourth, y to the sixth, over x to the seventh, y squared. So this one's really similar to the last example in that it has that power rule all the way on the outside, but this is a combination between the quotient rule and the power rule. So what I'm going to do is I'm going to simplify the inside by using the quotient rule first, then we'll do the power rule after that. So To simplify the inside, we're going to use the quotient rule. I only have the 2 as a coefficient, so that stays on top because there's nothing to simplify it with. Then for our x's, we're looking for the highest exponent. The highest exponent is 7. It's on the bottom, so I'm going to leave the x's on the bottom. It'll be x to the 7th minus 4. And then for our y's, this bottom one is y to the 1st because it doesn't have an exponent. And because the y on the top has the highest exponent, we leave the y's on top. So y to the 6th minus 1. And once again, we're going to put that all in parentheses and put a squared on that because we don't want to forget about the power rule that we have to do. We're going to simplify that a little bit by actually subtracting the exponent. So I'm going to have 2y to the 5th on the top over x to the 3rd on the bottom. And that's all squared. Now, we didn't do this in the power rule assignment, but when you have a fraction on the inside of these parentheses and you're taking the power to it, you still take the power to every chunk. It's just that you take it, like, so this one you'll take it to the 2, to the 5, and to the x. It looks a little bit different because it's a fraction instead of just a big slew of numbers, but it still works the same. So I'm going to have 2 squared y to the 5th times 2 over x to the 3rd times 2. And we can simplify that. 2 squared is 4, and then we'd have y to the 10th because 5 times 2 is 10 over x to the 6th because 3 times 2 is 6. And this is my final answer, my final simplified answer. All right, one more example. And this example is 2x to the 6th, y to the 3rd times x squared, y to the 5th cubed over x to the 5th, y to the 10th. Now, this one is a combination of all three things, the product rule, quotient rule, and power rule. When we do this, it's going to be easiest to simplify the top first, but this top has a power rule and a product rule in it. I'm going to use the power rule first just to get rid of the parentheses, and then we can use the product rule. After we use the product rule, then it's going to turn into a fraction, so then we can use the quotient rule. So let's start with the power rule. I'm going to distribute the 3 to the x and the y, which would change this to 2x to the 6th, y to the 3rd times x to the 2 times 3, y to the 5 times 3, and that's all over x to the 5th, y to the 10th. I'm going to simplify that a little bit by actually multiplying the exponents. So I'm going to have 2x to the 6th, y to the 3rd, times x to the 6th, y to the 15th, over x to the 5th, y to the 10th. Now I'm going to use the product rule on the top. So there's only a 2 in there. There's no other coefficient. So that 2 just kind of sticks there. Then for our x's, we're going to have x to the 6th plus 6 because both of the exponents on the 6's, or both of the exponents, for both of the x's on top have exponents of 6. Oh my goodness, that was a tongue twister. And then our y's will be y to the 3rd plus 15 because those are our exponents on the y on the top. And then the bottom is x to the 5th, y to the 10th because I haven't touched that yet. Now we're going to simplify that by actually adding the exponents. So I'm going to have 2x to the 12th, y to the 18th over x to the 5th, y to the 10th. Now, so we've done the product or the power rule, then we did the product rule. Now we just have to do the quotient rule. So to do the quotient rule, there's only a coefficient of 2 and it's on the top, so we're going to leave it on top. And then our x's, we're looking for the highest exponent, which is 12. That's also on the top, so I'm going to have x to the 12 minus 5. And then our y's, the highest exponent, is also on the top, so I'm going to have y to the 18th minus 10. Now, because everything ended up on top, we don't actually need to write out the fraction. We can just take away the fraction line. And then it just turns into a number, a whole number, or a whole term. So to simplify that, we'd have 2x to the 7th, y to the 8th. And this is our final simplified answer. And that's how we deal with combination exponents.